Hello. So today I'm trying this problem called products of array except self. Okay, so let's see how can I solve it. So it's basically just the product of everything except the number itself, and we shouldn't use division. And so what I'm thinking is, okay, we'll just have the product to the left, the product to the right, and then give the final result. So that would mean basically left products, right? So left products, let's call them, and then we would have it like this, right? And then we would go for in the array and just put them there. So if not left, if left product, which means it's not empty, we already pushed something there, then we could just take that. So actually I'm going to do I. So just do n to be the length of the array, right? And that will be range of n here, and that will be basically left products at left product. Let's call it at I would be equal to at I minus 1 multiplied by, so that would mean start at n at 1, because the first position would have just 1, right? Because the left product for 1, there is nothing, right? So basically left is excluding the current position. That's what we mean. So the left of I, so excluding I, is the product of everything excluding I minus 1 multiplied by nums at I minus 1, right? And then for n minus 1, that would mean we'd get everything except n minus 1. And then for I in the range for the going from the right side, we'd go by minus 1, and we'll stop when we reach 0, right? So for the right product, I would say it's going to be 1 too, right? But here it's going to be 1 in range of n, right? So that would mean here that I would need n to be outside. So I would need n here, and essentially this would be both equal to the same thing, essentially. Okay, I'm not sure if that would make them have a, yeah, let's see if that would work. Well, let's first try it without risk, and then so here for n minus 1 itself, well, we don't care, but for n minus 2, that's where we should start. So there the right product would be at position I equal to right product at position I plus 1, right? What we have so far. So that would mean multiplied by at I plus 1. So that would mean for n minus 2, we would give the number at position n minus 1, and we'll keep going like that. And now to get the final result, well, for the final result, let's just make a list like this, and that would be for I in range of n, right? And so it would be res.append left product at I multiplied by right product at I, right? So left of it multiplied by the right of it, and then at the end we just return that. Okay, looks good. So it says bigger or equal to 1, so let's take 2. So this should be 2 and 1, right? should be 2 and 1. Okay. Yeah, I think we can submit. Okay, so that passes. Now one thing I want to try is what I mentioned earlier, like does this work? And we can do res here. Yeah, I forgot this. Uh-oh, okay, that looks way out of, yeah. Yeah, I think what I thought is right. It's, it makes it, when you change one, you change the other one. Okay. Okay, so now let's see how other people solved it. Okay, so let's continue here. So I solved it using this left product and right product thing, which is what I have here for this solution. So I'm just going to put this on top. So essentially this one is just taking the left product, the right product, computing the left side, and then computing the left product. Okay. Okay. Okay, so now there is this follow-up that says if we can solve it with constant space complexity, and the output array does not count as extra space for the purpose of space complexity analysis. So the output array does not count as extra space. Okay, so basically, essentially, we need to get rid of just left product and right product. Essentially, that's what this is saying. So let's see this without extra space solution. Okay, so essentially it's just taking the array and this is kind of computing the left product, right, in the output. And then for the right product, we don't need to do that. We can just essentially just keep multiplying so just keep multiplying and get the right that way, right, with just one variable, and that way we don't need to use that much space, I guess. Okay, this looks reasonable. Let me try it out. So I think this is kind of it in a way, maybe not. Okay, let me just write it. So it's like this, solution 2. And we would have still, this is length of nums, and we would have res right away, which would be same thing, 1 for range of n, And we will need to just compute it in the same way that we computed it before. So it's like res of I equal res of I minus 1 multiplied by names of I minus 1, right? And now for the right portion, we'll just say 1, and then we would go backwards still. So minus 2, and then minus 1, and then we would say, okay, so res I we need to get multiplied by right, the previous writer, okay? And the new right would be multiplied by the current number so that it can be used for the next one, and at the end we can just return res. So if I submit this, okay, that's not quite right. (24, 12, 8, 6), yeah. So it's because we didn't start from 1. Because we want the last one to get multiplied by, which is n minus 1 res. Yeah, we need to update. Basically for n minus 2 we need to update with the number, so that's why. Okay, so that passes.